ये जो मैंने कोड भेजा है चैट में, इसमें मैंने मतलब मोस्टली ऑब्जर्व कर लिया था, बट एल्स वाले पार्ट में डाउट था कि अगर मतलब मैक्स साइज जो हम बना सकते हैं n-k+1 बना सकते हैं, तो अगर जो नंबर ऑफ वंस स्टार्टिंग से है, अगर वो मैक्स साइज के बराबर हो चुके हैं, एंड इसमें मतलब कि इसके बाद नहीं समझ नहीं आया मुझे कि अगर नंबर ऑफ वंस जो है वो अगर मैक्स साइज से कम है तो 1 आएगा, लेकिन उसके बाद श्योरली 2 आएगा, ये कैसे मतलब हो सकता है? हुँ, हुँ, ओके। हुँ, ओके। हुँ, 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 नॉट मच। हुँ, हुँ, फेल हुँ, हाँ, गॉट इट। हुँ, 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 श्योर नहीं है ना 1 है। मतलब इसके आगे 1 हो वो श्योर थोड़ी ना है। अच्छा, आंसर 1। हुँ, 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 समझ गया थोड़ा-सा। हुँ, हुँ, प्लस के लेस देन है। एक्सप्लेन ये 1 प्लस के लेस देन है। हुँ, हुँ, हुँ। हुँ, यस। हुँ, 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 यस। काउंट अच्छा। हाँ, हाँ, गॉट इट। हेलो, हेलो, हेलो। हुँ, Yes. Hmm. Yes. Yes. Hmm. Yes. 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 Yes.
Could you explain again? ये part.
Hmm.
Right.
Correct.
Um, okay, question. Second last पे ही two बनाना compulsory है क्या? Last पे zero बनाना compulsory है ना?
नहीं.
हाँ, okay.
Hmm.
Right, 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 right. Okay.
Yes.
हाँ,
Yes.
right.
Yes.
Mm,
Hmm. One minute.
Okay. Hmm.
Can you run it on a sample?
Right.
Can you run it on a sample?
थोड़ा zoom out.
Yes. 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 Mm. Yes. Correct. Mm. Yes. Correct. Yes. Got it.
Yeah, yeah. Yeah, yeah, yeah.
हेलो। हेलो। जस्ट लिसन 1 मिनट। हेलो हेलो। यस। सर, स्ट्रीम पे आवाज़ नहीं आ रही है। भाई, देखो, अभी नहीं आ रही है। आई एम। यस, टेक्निकली। स्विच स्विच योर माइक।
अरे
क्या पता। परम दरवाजो बंद।
हेलो हेलो हेलो, अभी आ रही है।
आवाज आ रही है।
यस,
हाँ हाँ, अभी
नाउ इट
आ
शुड
गई।
कम।
Nice.
भाई वाई यार, आज ही इशू आने थे सब। क्या करो
चल
अभी?
रहा है भाई। एक जगह एक प्लस हो गया और बाकी सब जगह माइनस हो गया भाई। ऐसा।
डी एक्सप्लेन, डी आई डू। अच्छा वापस रीडो, कुछ ज़्यादा किया नहीं। सो सॉरी फॉर द
तो
नो
रेटिंग्स
माइक।
अपडेट हो गई क्या? वेट। It system
नो नो
test
नो,
is not done, I believe.
रेटिंग अपडेट इज लेफ्ट।
Now system testing done. Nice. हाँ, ई तूने
हाँ
अरे फ्लैटन ठीक है। एनीवे,
हाँ हाँ,
व्हाट आई
सो
अदर
लेट्स डू
न्यूज़
डी।
व्हाट।
In D, the question is you are given two graphs. You have given starting node where token 1 and token 2 are present. In one operation, what you do is you go token 1 goes to an adjacent node. It has to move, and the cost of this operation is let's say token 1 move to a U1, token 2 move to a U2. My cost is absolute value of U1 minus U2, and this gets added. Now this process happens infinite number of times. So whenever this infinite number of times happens, I need to have some base case, or else my answer will always be infinity. Correct? When is my answer not going to increase? One thing to notice, if my U1 and U2 both are same, my absolute difference is 0. So at 1, like when I go to a U1, U2 which are same, my addition is 0. But I also have to make sure that the adjacent node to U1 and U2 has to have a common node, which is U3, U4. Both of them have to be equal. Why is that? Let's say I have 2, 2. Okay. 2 is connected to 3 over here, like not directed edge. And here 2 is connected to 1. Let's say this is 1 and this is 3. Now over here, if I reach 2, that is fine. I increase 0. But then coming back from 2, my cost increases by 2. So this I can't rely on. This increases my answer. But if it was something like this, and let's say 1 is here, then these two, then I can just 2 to 3, 3 to 2, 2 to 3, 3 to 2. I can just alternate. And here my answer will be 0. Like my addition to answer is 0. This I can do infinite number of times. So whatever cost to reach here is, that is my answer. Fair? Now, how do I get, like, now let's check what are the nodes which end, basically terminate, or which are good. So this I can do for every node. For every node. Like for every node, in both the graphs there should be a common next node. Then only that node is good or terminating. Okay. This is the most important step to do. This you can do in basically n into m. Yeah. So this you can do in that. Basically for every node you check the edges, and like not n into m, it is n into n only. What if they are distinct and stuff? So approximate n square, but n square also works. It's 1000. Now then what to do? Then you can do a very common Dijkstra, like you can do Dijkstra, which is cost I and j. What is cost? Cost is simply the cost you've taken to reach this state. Okay. I is basically where T1 is, basically the token 1 is, and J is basically where token 2 is. Okay. Now in Dijkstra, we maintain a visited array. In the normal cost, comma I Dijkstra, I store only n size array. I store an array of n, which is visited. But over here, I need to store basically dp or visited of I comma j. Okay, this I need to store. This basically this makes sure that I don't visit this particular state with a greater cost. If I do, that means it is basically harming me. It'll lead to more infinite cases. So yes, so I need to make sure. So this just makes sure that I don't repeat this particular state with a greater cost, with similar cost, so whatever. Now, when do I terminate? Like basically this, you can do this Dijkstra. You'll need to have base case. What is the terminating condition? Where I equals j, and it is good. Basically, it is terminating, that the node is terminating. Okay. So that is a terminating condition. Here you return cost. Here you simply return cost. And if the entire Dijkstra is done and you never reach this terminating condition, then answer is -1 because you can't reach anything. Fair enough? Does that make sense? Cool. So yes, I'll show the code. So
Isn't it possible that
yes, it's good.
am I audible?
It is a bit choppy, but yeah, you can still speak, I think.
Yeah, I was wondering,
Wait, your network is like, your audio is
like,
very.
is it possible that we need to go over the same nodes ij again and again?
Okay, yeah. So yeah.
Okay, okay.
Jenil,
No, no,
just
no,
One
wait.
a
I
second.
understood it out. I understood it out. So let's say I have ij. Dijkstra makes sure that I reach it in the minimum cost possible, right? Dijkstra makes sure this happens.
Yeah.
Now, if I reach the same I comma j with something greater, with some cost which is greater, right? It will be greater because I'm reaching it after I've already reached it, right? So if I do this, isn't this part of the infinite solution where the answer is infinitely large? Like, I am doing something like this, like there is some kind of cycle where I am reaching the same node, but I am not terminating. I'll keep on going this, right? If I've reached here with some cost and some other path, I've, like, basically this is a node. Let's say I've reached here with this path which costs C1, and there is another path which leads to this node with cost C2, but C2 is greater. Now it doesn't make sense to like go with this cost. Why? It's just because, like, then you won't, like, you'll be repeating a lot of times, and your answer is always the min cost. I'm always returning the min cost, and otherwise it's always -1, right? So all the other cases don't really matter.
Okay, got it, got it. Thank you.
just a question.
हाँ.
To summarize, हम लोग अभी तक we are just finding good nodes जिसमें it cycles to itself at 0 cost, है ना? And we are running a
Not
Dijkstra.
cycles to yeah, kind of cycles to itself, but basically like two nodes pairs where both of them are same. Two adjacent
हाँ
nodes where both are same. That's the main thing.
हाँ technically it cycles to itself and with same nodes. हाँ.
Yes.
So after that we do a Dijkstra to all the good nodes and उसका minimum cost print कर.
No. I do Dijkstra normally.
हाँ I mean to and फिर उसके बाद good nodes का minimum zero.
The first good node I reach
हाँ.
is your answer.
Okay, right.
Because I.
But what if we let it run till we have visited everything? Would it work then?
It would work, but the point of Dijkstra is to get the minimum cost, no? Now,
Okay.
if I've already reached a good node with a minimum cost, if I reach some other node, okay, with some cost, other greater cost, my answer still won't change.
Okay.
So
Got
it's always better to, like, just return all, like, just print it out and return.
Got it.
So if you come to the code, I basically check if a common node exists for every node, and I mark it as good. It's a boolean 1 or 0. Now I store the extra thing.
Okay, wait, how did you do that good node wala thing?
Okay. So for every node, I insert all the adjacent nodes in A into a set.
Okay.
Now for all the nodes in B, if all the adjacent nodes in B, if it is present in A, in the adjacent nodes I've already counted, basically. Now let's say this has this nodes. So 2, 3, 5. So I have a set of 2, 3, 5.
Okay.
In graph 2, I have 6, 7, 3. Now 3 is common, right?
Right.
So this node is good.
Okay.
So like if I have a common node, basically I found a matching node. So I make it
Oh.
good and then break it out, break out.
But
That's it.
why do we not need cycles? मतलब अच्छा cycle of 2 भी चलेगा क्या?
Cycle of 2, that is the only like that is the minimum cycle possible, right?
Right. Oh, okay, got it.
Anything else.
Will form a cycle of 2.
No,
Got
let's say a cycle of 2 is not possible. So
Hmm.
like there must be some cost here, but let's say this is 0, this cost is 0, this cost is 0, and I do an infinite loop.
Right.
I'm still adding a C over here, right? All of them have to be a 0 for it to be bigger cycle.
Right,
So
right.
bigger cycle compressed down to a smaller cycle. So yeah, that's it.
Right. Got it.
Yeah. So then it's just normal, like this is a very standard Dijkstra code with this added base case. That's it.
Got it.
And here, instead of going to one child, I go to child A and child B. I iterate over all children. That's it. That's the only. This part and this part are the only additions to the Dijkstra, which everyone is familiar with.
नहीं भी करे तो भी चलेगा ना मतलब
क्या?
नहीं भी करे ये Dijkstra वाला addition तो भी चलेगा ना technically.
This
If we
addition.
do not हाँ if we do not stop it तो भी चलना तो चाहिए.
Then how will you know कि it is a -1?
Basically I keep the answer as -1. Then for each distance to a good node मैं min लेता रहता हूँ.
हाँ, you can do that also. Like you like instead of returning, you can take a min cost also. That is also fine.
हाँ.
But answer is anyways going to be the same. Doesn't matter. So then let's move on to E1. If rating gets updated, bhai, let me know. Still not updated. Cool. Yes. So E1 is like very interesting problem. I submitted like in the last 2 minutes were left. I had submitted, and I was just reloading every single time till it got AC. It got AC like after 2-3 minutes because it is a long 34-35 cases, but pre-test only. So yeah. Now you're given Aij, which is a 2D array. Now you in one operation you do the following: you choose you choose a particular row, and you choose a particular x. Then you add the element to the beginning of the kth array. You assign x to the last element of kth array, and remove the last element. I'll just help you visualize what the operation looks like. Okay. Now let's say I want to add 10 here. Okay. So what does it turn out to be? 1, 2, 3. 10 gets added. 4, 5 remain. 6 gets removed, and x becomes 6. So over here I get a 6, 7, 8. So in the end what is happening is 10 gets inserted here, and the last element of the entire matrix gets removed. 9 gets removed and 10 gets added. Can you see this? Yes, no. Hello. Huh. So that is one operation. Basically, wherever I do,
और रेटिंग चेंजेस आ गए.
oof. Let's see what happens. Where is it? Oh, plus 198.
Whoa,
Let's go.
congrats.
2015. Yes.
Nice.
Nice. What was
मास्टर
the
पोस्ट से दिया और भी रेटिंग चाहिए होती है क्या, मतलब रैंक?
Huh?
मास्टर पोस्ट के लिए
No,
आपकी
no,
101.
this rank is more than enough to reach master, but I was too far behind.
Okay.
My perf was basically into 4 plus what was I before that? 18, 13. Oh, IGM perf once again.
Oh, congrats.
Crazy. IGM only, no? Wait.
हाँ.
IGM.
Great.
GM is 24. Okay. Crazy, crazy. Let's go. So now, so in one operation, what is happening is I add x to the first position of the kth array, and the last element of like everything else just gets pushed back, and this last number remains. Okay. So now, how do now? What is the question? You're given A, you're given B. You need to find the minimum operations to get to B from A by doing these operations. Okay. So it is like now for this, my answer is 1 because I just did one operation. But let's take a bigger example. I'll make some cases and then I'll explain how I got the intuition for this. 7, 8, 9. And let's say my B error was 10, 1, 2, 3, 11, 4, 5, 6, 7. Okay. What is the minimum operation? I am saying it is 2. How is it 2? First, if you see 4, 5, 6, 7, I can just I'll do an operation over here which is 11. So wait, I'll just translate. I do 11 or add 11 over here. So this becomes 1, 2, 3, 11, 4, 5, 6, 7, 8. And then I add 10 over here. So which, wait, I'll do this. 10. So total, I take 2 operations to reach this state. Now, I am given A, I am given B. I need to figure out these 2 operations, the number of operations. Now, E2 is basically figure out the actual operations, but E1 is this. Now, like a very a more complicated case was this, where it's not that evident what is happening. Let's say I do this 10, 1, 2, 3, 4, 11, 5, 6, 7. Okay. Over here, I have to, literally I have to do 7. I need to do 7, then 6, then 5, then 4, then 11, then 4, then 10. 7 in index 2, basically the second array, second array, second array, second array, second array, first array. So if you just look at it, what is happening is 9 gets removed, 7 gets added, 8 gets removed, 6 gets added, 7 gets removed, 5 gets added, 6 gets removed, 11 gets added, 5 gets removed, 4 gets added, and then 10 gets added, 4 gets removed. That is how I get 10, 1, 2, 3, 4, 11, 5, 6, 7. There is no other way. You can look through all the possible combinations. There is no other way to do this. So some approaches which I had, like I'll explain how I thought of it, so that somehow, like, so that you understand, and probably in the future if something like this happens, you can solve just like how I did. I am not saying my method is the best. I am just saying it exists, and I did it like this. Okay. So the way I work is I work with doing some cases and observing some pattern over here. So I am just doing that in this case. So over here, like I have these two examples. Okay. From these two examples, let's try to generate my answer. Okay. So now, in the starting position, if I don't do an operation, I'll need to have a 1 here. But I don't have a 1 here. So that means I did an operation for sure in this position. So I need to do a +1. Okay. Future doesn't matter. Currently I did this operation. Yes, no? Wait, bhai, where is Utkarsh? Wait, I'll let Utkarsh.
Can you please repeat that last part little bit?
Yeah, I'll repeat it. Utkarsh wanted to join.
That example, the tricky one which you've shown.
Yes. Just a minute. Okay. So this is the tricky example. Yeah. In here, what I'm saying is, I have to do 1, 2, 3, 4, 5, 6 operations. This you can verify with, I verified it with lot of cases and stuff. Like I simulated, did lot of kind of stuff. But yeah, answer to this is 6. Answer to this is 2. And what are the 6 operations? I'll do 7 to, no, basically wait, 2, 7, 2, 6, 2, 5, 2, 4, 2, 11, 2, 4, and finally 110. Okay. Did you see this, understand kind of?
Yeah. Like,
Huh.
so one is like the 0 index, right?
Yeah,
The first row.
like for one index. Like I'm doing 2 means I'm doing on this, 1 means I'm doing on this.
Yeah. Okay.
Yeah. So now for this my answer is 2. For this my answer is 6. Now let's try to simulate how I will try to answer my answer this question, okay? Because at the end of the day, my code just has these two, understand just these two arrays, and like since n into m is 3, 3, 5, I have to do it in n into m. I have no other choice. So basically, n into m is basically iterating overall. So how will I just iterate overall, kind of, and get the answer is what I thought of. So one thing to notice, let's say I have a pointer over here, I have a pointer over here. Okay, if both are equal, I can just move ahead. But right now both are not equal. Like, so what happens is I need to do some operation to get this 10 in this place. Correct. Now, when can I do this operation? I can do this operation only and only if I am at the start, right? Basically, start of that array. Start of that specific array. Yes, no. Then only I can do that operation. That is my
Yeah.
limit. So since I'm at the start, this is fine. I can do a +1 operation and I can move on to this. Fair? Now 1-1 match, I can just move on. 2-2 match, I can move on. 3-3 match, I can move on. So now my pointer is at 4 and 11. 4, 11 are not equal. But can I do this operation? Can I add an 11 by just doing one operation? The answer is yes. Why? Since I have done one operation earlier, if I just do 11 before this operation, this becomes the start, right? Like before this has been shifted, this technically is at this position, right? Is at the start of that index, start of that array. Yes, no?
Yeah, yeah.
Yeah. So basically what I'm doing is, if I am at an index, if I have done some operation such that I can reach the start, this is valid. Okay, so I do a +1 here. Ouch. Copy. Now, then I move on my pointer to here. 4-4 match, 5-5 match, 6-6 match, 7-7 match, and that's it. I matched everything. So what is the total number of operations I took? What is the calculation I did? 2 only, right? Yes, no. So 2 and I got this answer. So, oh damn, magic. This is magic. Okay, I think I'm on the right track. This is exactly what I thought of. I made this case. I was like, let's do step by step. Can I do this operation? Yes, no, and stuff. Then I made this case where I just basically I swapped these two values around, and I'm like, let's calculate. Let's see what should I do in this case. Okay, that's what I did. Till this position, I had +1 and everything matched. I was here and I was here. Okay, these two match, so I am at 5 and I am at 11. Correct? In this case, these two don't match. Yes? Now, can I have an 11 at the start of some particular some particular operation? No, because I've only done one operation. So I can just shift it at max once. And this is not the start. Yes? Hello?
Okay, got it. Got it.
Huh. So since this is not the start, I'll have to do these operations, basically. I'll have to do 4, 11, 5, 6, 7. Why? Why 4 also? Because to have an 11, I need to have a 4 earlier. Make sense? Hello? So because like I have done one shift, okay, one shift is okay, that's all good. But after that, basically the cost is, so now the total, this total answer, total increase is n into m, this total. Now this row, the previous row has been sorted out. The previous row I have built completely. So I can do minus I into m. What is I? I is basically my current row. If I do zero based indexing, basically I have number of rows I've done before me. And this I can do minus answer. Why am I doing minus answer? Because I've shifted some numbers around, right? I have removed some numbers and stuff. So that is why I do minus answer here. This minus answer is very important. Okay? Hello. Yeah. So this is my increase when is this happening? When no match and can't bring to first. Okay. If can, to I like if no match and can bring to first, then answer plus plus. Okay. What is this can bring to first? Okay. So this is basically the jth index you are at minus your already taken operations should be less than equal to 0. So this is the main case. Why is that? That means I have done some operations. I don't know which operations I've done. I've done some operations, but I can do this current operation after doing some number of operations, some x number of operations. I insert this basically. Make sense?
Yeah.
So that is it. That is the entire logic for this. And you just get AC from with this. Like I had done some mistakes and I'll tell you what mistakes I've done. And yes, I'll just go to the code and you can see like it's literally that what I'm doing. Okay. I take the input. Now I have ij and xy. Ij represents the position at A, xy represents position at B. Now I do this loop till the x, which is the row, is less than n, because that is the only valid part. If both are same, I increment the j and y. Basically, I go to the right. But if I am at 3, I need to go to 4, right? Which is basically if I am jumping from 0, 2 to 1, 0. So that is what I'm doing. That if j is equal to m, I do j equals 0 and I plus plus. This car doesn't really matter. And y equals m, same thing. I just go to the next one. Now this is the else case where it is no match. No match mein I did this j minus, it's not j, it's y, because y is that row. Y minus answer less than equal to 0. Then I can just increment, I can do normal increment and I can increment the answer. Okay, and that is the else case where I just this what I'm doing actually I think doesn't really matter, but I had just done this because let's say I have come this far in this. Actually min will always be this, so I'll just make this submission also just cleaner. This should also be. I had taken min because I had some conditions here, and this is my this, and then I break. Breaking is important because then basically I fulfilled the entire other arrow. This looks. That is it. Any doubts over here? Basically, like this condition was the most important part. Where can I just increase by 1 and where I have to just increase everything. That I figured out by basically looking at this case. I understood that I can't do anything over here. And yeah, firstly I'll tell you now why I got WS over here. My first WA, what I had done was I had done minus cur over here. Cur is basically my current. It shouldn't be cur, it should be answer. That was my main WA. And even before the WA, how I came up with this y minus answer was for this particular test case. Like if I had just done, like first I was doing this y equals 0 or j equals 0, and here I was getting something greater, like I was getting 8 over here, and 8 is greater than the required 6. So I was like, why is this? And in here what is happening is I have done 2 operations beforehand. So if I've done 2 operations beforehand, I can do this after that and stuff. So that is where the y minus answer came in. And after y minus answer came in, I had just, this is just silly mistakes, and then I got a C. That's it. Any doubts?
What was the role of current variable?
Current variable doesn't matter. I just removed it. Like in my logic, the current variable is basically operations I've done in this row. That was my main thinking, and that is why I was just doing minus current, but just current is just stupid and doesn't matter. I was doing this when I was like with 5 minutes left, so at that time you don't think much, you just code out and you get AC. So that is where I just thought that this might happen. I just did current and got AC. And then I did answer. I got WA. I was like, yes, this is where it fails, and I got AC. And failing case also, luckily at that time I just wrote this case out, and this case only failed. So I was like, yes, this case is failing. That means something bad is happening. And yes, I just debugged that and I got it. So yeah, making cases and making edge cases are very important skill to have, and if you've done that, then you can try to overfit your answer, which is what I did. And yeah. Cool. I guess we can say bye bye to stream. Bye bye stream. Meet you with the next PC.